Okay, hello and welcome to the Tempest How To video. My name is Duncan Lister and I'm a PhD student here at the University of Oxford, and I'm the developer behind Tempest. Now, I'm going to take you through how to get this up and running on your own computer. So we're starting here at the GitHub page, and if we scroll down, we'll get to the README for the piece of software. And this gives you basically the instructions for how to get this started. So I'm going to go through these one at a time and help you to get it up and running on your own computer. So Tempest is a thermophysical body model, and that means it solves a 1D thermal conduction equation for multiple facets of a model. Now, these facets can shadow each other, and they have things like radiative self-heating, so one facet can heat another through its own radiation. And by following through a series of processes, we come to a final temperature distribution for the body that we're looking at. And I'll go through that in a bit more detail a little bit later. But to get started, we're just going to download the software. So we're going to scroll to the top here, we're going to hit this code button and download a zip. Now I'm going to save that to my downloads folder, and hopefully it'll be quick because I'm on good Wi-Fi here in the office. There we go. I can click on that to unzip it. It's going to open up in downloads, and I'm just going to drag it to my desktop. Okay, now I can open this up and see what's inside the folder. So we've got a few different folders. We've got data, output, source, which is where all the code is kept. And to get this up and running, we're going to be using terminal. So I can just do command space to open up a terminal window. Here we go. And I'm going to start off by navigating to the Tempest folder. So this is step 2. So I know this is in desktop. There we go. Now, when you first open this up, it's going to create a virtual environment. So this should give you all of the dependencies that you need to start it running. And it should have Python set up for you already. But if not, you can double check those things here. So step 3 and 4. So I'm going to start by checking that I've got the right version of Python installed. So Python dash version. There we go. And I can see I've got Python 3.13.1, so 3 point anything should be fine. Now I'm going to check that the dependencies are installed. So pip install -r requirements. Oh no. Requirements.txt. There we go. Now this is going to go through and check all of the requirements in the requirements.txt file, and anything that's not installed, it will update or install. And so the first time you run this, it might take a little while. Again, I've just downloaded this for the first time, so it is going to take a minute to go through this. So once it's done this, I'm then going to put in this command. So this is how we run the model. So we've got Python tempest.py, and that's the main script. And then I'm going to tell it which config file to use. Now the config file is where you set up your physical parameters for your model. So that's where you tell the model what shape model to use. So whether you want to use a sphere or something more complicated. It's also where you set the physical parameters for the model. So for example, the thermal inertia of the body that you're looking at, and the solar distance and so on. Then once you hit that command, Tempest is going to start off by setting up. Now there's a flowchart here under model architecture, which tells you a bit more about how that works. So the first thing it does is it calculates the insolation curve for each facet. So it looks at where it is, how it rotates relative to the sun, and it works out how much sunlight that facet receives. Then it sets an initial temperature. So over one rotation of the body, you have an average insolation, and basically the black body temperature of that average insolation is your first guess of the temperature of that facet. And then the model iterates through multiple days looking for convergence. So it updates the surface temperature based on the insolation, radiation received from other facets, shadowing, and so on. And then at the end of each day, it checks if that temperature is substantially different to the day before using this convergence check, and you can set the boundary, the target that it looks for. And once it's done that, it's finished running, and you should have your result. Okay, so we're done checking those packages. So I'm now going to put in that command and hit run. Now, the first time you run this, it does take a little bit longer. That's because it's setting up everything for the first time. It also does things like, for example, if you're looking at a complicated shape model, If you run the same shape model a second time, it will have already cached the insolation, so it knows how much sunlight is received based on the shape model and the rotation and the solar distance. So it will run significantly quicker the next couple of times, but for now we'll just look at this. Now while we're doing this, I'll show you the config file. So I'm going to open up a new terminal window. I'm going to navigate back to the Tempest folder, and then the config is stored in data. So I'm going to do code to open up VS Code, data, config, and then example config. So we can have a look at this. So it's going to hopefully open up in VS Code. Visual Studio Code is just a really good integrated development environment IDE that I use. It color codes everything in this YAML file, which is really handy. And so here you can see where you can set up your model. So one of the most important things here is your shape model file, and you'll find all the shape models also under data. Then you can set up your physical parameters, and then you can go through, change your solar distance. There's various advanced modeling options which you might want to play around with a bit later. And then you've got your plotting options as well. So for example, your animation settings. Okay, I can see it's running now. This is a small model, so it runs really quickly. And here we go. So this is the output. Now it's just changed the formatting when I dragged it across my windows. But this is what you get out. So this is your temperature distribution animation. So this is set in here in animate final day temperature distribution set to true. If you change it to false, this window won't pop up. The other thing you can do if you don't want it to pop up is set it to run in remote mode. So this is running as if it's running on a server. You'll want to do this if you actually are running on a server, because you don't want the images to pop up then, and it'll save the parameters for this animation so you can look at it later. Now once we're here, we can drag the model around. We can hit R if we want to reset our view. We can right click on a facet to select it, and then that's just brought up another window over here, and this is the diurnal temperature curve. So this is just showing us how this facet varies in temperature over time throughout one rotation. Now within this window, if I want to, I can hit T to toggle between local and global time. So we're in global time mode now, local time, sorry, and then we can go back to global time. If I press space to play this again, you can see that red dotted line advancing to show us where in the animation we are. Now I can also select multiple facets. If you select too many facets, it gets a bit buggy, so you can hit C again to clear it. So that's probably everything I want to do in here. One more thing, you can hit D if you want, and that will save this data. So if I select, say I want to compare this facet with one at the pole, I can then hit D, and that saves our animation data. So you can see that here. It tells us where it saved it, and then I'm done with the model, so I can close it down. It sometimes does take a second to close, particularly if you've just saved something. So there we go. Okay, so now if I want to have a look at that data, let me just, oops, I've got things all over my screen so I can't actually see that. I'm going to close that down. Now, if I want to, I can go to data here, output, and user saved data, so just following this path here, and that takes me to this file. So this is named as the name of the shape model. So 500 meter icosphere with 80 facets is the name of the shape model, and then it's got the date and time that it was saved. So hopefully using that you can find any of these saved outputs. So I can click on this, and then in here I should have a CSV file which has those temperatures and time steps. So I can inspect that, use it later for data analysis, whatever we want to do. Not quite sure why that's not opening. There we go. So yeah, you can see those two facets. It gives you the facet ID number as well, so that you can find it again, and you can hard code that if you want, if you only want to look at certain facets. So that's pretty much the process for running it. Is there anything I haven't said? The most important thing to know is that this is quite a small piece of software. It's not currently being used by thousands and thousands of people. So if you do have issues with it, please reach out to me directly. My email is duncan.lister@physics.ox.ac.uk, and you'll see up here my name, Lister, is spelled with a Y. If you do have any questions or you find any bugs and so on, please let me know, and I'll do my best to fix them and help you out. And I'd love to know what you're doing with the model. If you are working with it, then yeah, let me know. I'd love to see what you have going. So yeah, good luck, and I'll leave you there.